So today we will discuss that coordination compound. What is the learning objective? Now to understand the important terms used in that coordination compound and to explain the nomenclature of coordination compound. So it is a very large chapter. Today only we discuss these two topics. What are the keyword? Now double salt, central ion, ligand, chelating effect. To learn what is addition compound or molecular compound. Now, when a solution of two or more salt are mixed in their simple molecular proportion and then evaporated, a crystal of new compound is separate out. This new compound is called addition compound or molecular compound. Now, based on its stability, there are two type of that molecular compound, double salt and complex salt. So, in this chapter we mainly discuss that complex salt. Okay. Now double salt, see, actually it can only retain its structure in solid state. In aqueous solution it dissociate into constituting ion, but complex salt it can also retain its that structure in solid state as well as in that aqueous state. Now double salt, see, now that all that three types of alum. Okay. Now first one, that general alum. Now general alum, see, that K2SO4 dot Al2SO4 whole 3 dot 24 water, that is general alum. Now we represent that double salt by that dot. Okay. That here see three different compound in a particular stoichiometric ratio. So we put dot between these molecules. So general alum, its color white. Now ferric alum, all these are addition, or that means double salt. Ferric alum, see, K2SO4, only that trivalent, that metal, that will change, Fe2SO4 whole 3 dot 24 water. Now that one, that reddish brown. Now chrome salt, chrome alum, say K2SO4 dot Cr2SO4 whole 3 dot 24 water. Its color is green. Now complex salt, see, potassium ferrocyanide, that is complex salt. Now how you can easily identify complex salt by that third bracket. Okay, there is a third bracket. Actually this is called coordination entity. Now see the difference between that coordination compound and that double salt. Okay. Now first one, see, now coordination compound, it contains two parts, that coordination entity and that ionization zone. Now in coordination entity, that within that third bracket, that is called coordination entity, it contains central metal ion and ligand and coordinate bond. Okay. That's what is called coordination compound, and that outside third bracket, that is ionization zone. Okay. And coordination compound, that one stable, they do not dissociate into simple ion. So in potassium ferrocyanide we cannot get that taste of iron, or we cannot get the taste of that cyanide. Okay, because they do not dissociate into that constituting ion in aqueous solution. But double salt, see, it easily dissociate into constituting ion. More salt, so it will dissociate into Fe2 plus, SO4 2 minus, NH4 plus, SO4 2 minus. Okay, it will give its constituting ion in that aqueous solution. So double salt does not retain their property or retain their structure in aqueous that medium. So coordination compound stable, double salt, that one unstable. Important terms used in that coordination compound. First one, that coordination entity, that within that third bracket, that part is called coordination entity. So this one coordination entity. And that iron that is central ion, and that cyanide, this one ligand. So within that third bucket, that part is coordination entity. Now in that case, a ligand, it may be neutral, it may be that negative, it may be positive, and that central atom, now generally transition that element, okay, act as a central atom, and they must have that vacant d orbital, so that they can accept that lone pair, because see, the bond between that ligand and central that atom, that is coordinate bond. So the central atom must have that vacant, that orbital, to accept that lone pair of that ligand. Now central ion, that one, see, now in this case, remember one point, central ion accept lone pair from the ligand. So central ion act as a Lewis acid, and ligand donates lone pair to that central ion. So ligand act as a Lewis base. Now ligand, that it may be positive, may be neutral, may be that negative. Now see, types of ligand. Monodentate ligand, only one donor site, okay, monodentate ligand, it has only one donor site. See, for example, see ammonia, okay, monodentate ligand. Water, now oxygen contain two lone pair, but one donor site, so that's why that is also monodentate ligand. Cyanide, all that halides are monodentate ligand. Bidentate ligand, two donor site, see ethylene diamine, CH2NH2, CH2NH2, it is a neutral ligand, that bidentate ligand, ethylene diamine. Now oxalate, CO minus, CO minus, oxalate. Now oxalate, that is also bidentate ligand. Now tridentate ligand, say glycerol, CH2OH, CHOH, CH2OH, glycerol, three donor site, okay, tridentate ligand. Tridentate ligand. Now chelating ligand, now which form a cage-like structure with the central atom, that is chelating ligand. Generally that polydentate ligand act as a chelating ligand. For example, say EDTA, ethylene diamine tetraacetate, EDTA, that is a chelating ligand. Now see, it form a cage-like structure, that's why it is called chelating ligand. See, that EDTA form a chelating, see in that way, ethylene diamine tetraacetate, EDTA, see this one, ethylene diamine tetraacetate, CH2 CO minus, CH2 CO minus, again CH2 CO minus, CH2 CO minus, hexadentate, 1 2 3 4, these two nitrogen, total 6 donor site. EDTA, it is a hexadentate ligand, hexadentate ligand. So chelating means, see, cage-like structure, remember that term, cage-like structure, it form a cage-like structure with that multidentate ligand. Now ambidentate ligand, having two donor site, but use one of them in a particular that coordinate compound. For example, see cyanide, when it donates with carbon, it is cyanide. When it donates with that nitrogen, it is isocyanide. Then NO2, when it combine N, then N nitrito. When it combine with O, It is called O nitrito, ambidentate ligand. Okay, two donor side, two or more donor side, but in a particular coordinate compound use one of them. They cannot use both. So it is ambidentate ligand. Now coordination number, see the total number of coordinate bond in that coordination zone, that is coordination number. Now coordination number actually indicate that secondary valency. Now coordination pair, that within that third bracket, okay, that part is called coordination pair or coordination entity, that central ion and that ligand, that part in that square bracket or third bracket, that part is called coordination sphere. Now Werner theory of that coordination compound. Now in coordination there are two type of valency, primary and that secondary. Actually that ionization zone for this one, see that third outside that third bracket 3 chlorine, so its primary valency is 3, and see inside that third bracket total 6 ligand, so its secondary valency is 6. Okay, secondary valency indicates its coordination number, primary valency indicates that number of ion is produced. Okay, now Werner initially that prepared different that coordination compound. Okay, now important things is that nomenclature. Just you have to remember few rules. First one, now you have to always name that positive part first, then that negative part. Now the naming of that coordination entity, first we have to name that ligand according to their that alphabetic order, ligand, then that central ion. Now if that coordination part it is positive, then there is no change in the name of that central ion. Okay, but if that central ion that present in that negative part, that means if the charge of the coordination entity is negative, then you have to add 8 with that central that atom, and you have to that write the oxidation number of that central atom. See this one, it is a negative entity. Okay, negative entity, so that's why 8 is there, nickelate 8 is there. Okay, now 4, so tetra cyano. Okay, actually according to that new convention it is cyanido, tetra cyanido nickelate 2. Now see that charge calculation, see overall charge minus 2, cyanide minus 1 into 4 minus 4, that means nickel is plus 2, that's why it is written nickelate 2, tetra cyanido nickelate 2. Now this one, see this one chlorine minus 1, so cobalt here that will be plus 3, so hexachlorido. Okay, chloro old convention, new convention chlorido, hexachlorido, that one also negative entity, so cobaltate 3. Next positive, no change in that central that atom, say only cobalt, so in that case ammonia chlorine. Now according to that alphabetic order, ammonia first, so tetraamine. Okay, now actually there will be double A and double M. Okay, double A double M, tetraamine double A double N, remember that, not amine amine, it is ammine amine. Okay, tetraamine dichlorido cobalt 3 ion. Now charge you calculate, neutral 0, that one minus 2, so minus 2 outside is plus 1, so cobalt will be plus 3. Next one, see now in that case in question it will be mentioned that it will attach with nitrogen, or actually it is attached with nitrogen because NO2, otherwise it will be ONO. Okay, so now positive part first, sodium. Now in ionization zone we do not have to mention the number of ion. See here are 3 sodium, but it is only sodium. Okay, now there is a gap between that positive and negative entity, there is a gap. Okay, so sodium, then gap, hexa, it will be N nitrito. Okay, hexa N nitrito cobaltate 3, hexa N nitrito, new convention N nitrito, hexa N nitrito cobaltate 3. Then see, now this is chelating ligand. Okay, so that's why within first bracket ethylene diamine within first, and it will be bis. Okay, if it is a chelating ligand or polysyllable ligand, you have to put that bis tris. Instead of di-tri, you have to use bis tris tetraquis. So dichlorido, bis ethylene diamine, chromium 3 sulfate. Okay, how we calculate the charge? Sulfate minus 2, so that will be plus 2, but 2 part total 2 is there, so plus 1. Now if that one 0, that one minus 2, so chromium that will be plus 3. So dichloro or dichlorido, bis ethylene diamine, chromium 3 sulfate.
Thank you for watching. If you are new in the channel, please subscribe my channel. Please like, share and comment on the videos. Please subscribe my channel to get more chemistry related video.